Sir, is it audible, sir?
Yes, sir. Audible.
Kesavaraji, sir?
Yes, sir. Audible and clear.
Audible now?
Yes, sir.
Sir?
Yes, sir. Audible.
Is it audible now?
Yes, sir. Yes.
Okay.
We'll start in 5 minutes, sir. Please wait, sir.
Yeah. Noises.
Thank you, sir. Thank you.
Fine. Good evening to one and all. I'm happy to welcome you all for the day 5 of our AICTE Atal sponsored FDP on Artificial Intelligence Edge Soft Computing. Now I request Ms. Darshini, Assistant Professor, Department of Computer Science, to welcome our today's session chief guest. Ma'am, please.
It is a great privilege to introduce our esteemed resource person, Dr. S. Lakshmana Pandian. He is a distinguished professor in the Department of Computer Science and Engineering at Pondicherry Engineering College. He completed his BE in Electrical and Electronic Engineering from Government College of Engineering, Tirunelveli in the year 1993. ME in Computer Science and Engineering from Anna University, Tirunelveli in the year 1998, where he secured university second rank. And he completed his PhD from Anna University, Chennai in the year 2011. With over 28 years of extensive experience in both teaching and research, he has made remarkable contribution of the fields of language technology, natural language processing, and embedded system. His research has resulted in numerous publications in international journals and presentation at prestigious global conferences. We are truly privileged to have him here with us today. Now I hand over session to Dr. S. Lakshmana Pandian, sir. Please, sir.
Is it audible now?
Yes, sir, audible.
Audible. Good evening, one and all. Okay. Now I am going to start my presentation. Thank you for your introductions and everything. Then I will start now. Then my screen is visible now.
Yes, sir. We can see, sir.
Okay. Saravana Kumar.
Sir?
Can you interact with me?
Yes, sir. Your screen is visible, sir.
Yes. Okay. Visible, right? Oh, full screen is visible, right? Okay.
Sir, yes,
then
sir.
I will start now. Okay, actually today topic is computer vision and speech processing. So in that the title is actually a vast book one, right? So computer vision is one topic and speech processing is another topic. Then we have to combine together as today presentations. So I am going to give that outline and also what is going on, then how we can go through that computer vision and everything. We can see that one, right? Almost I will cover some portions, right? Some portion may miss now. You can ask some question at the end. Wherever you want, then you can ask question. You can mute yourself, then you can ask question. Right. So today, first I am going to deal with the computer vision. Right. So we are here. What is the computer vision now? Now, how we are having that image and video, how we are going to store in system, and how we are going to have that, right? So the title is actually we have computer vision in the field of artificial intelligence. So this is one of the field of artificial intelligence. So it allows computer to interpret and analyze visual data. Visual data is image and video, right? Image as well as video. Image is actually we are having a two-dimensional image. So video is actually three-dimensional. So with two-dimensional and with the time. So with the time, then we are having frame by frame. We are moving now. So that frames also images, right? So we are in the computer vision is going to have that deal with that image and videos, right? Okay. Now we'll see that one. computer vision and speech processing is also we are having now. Then whatever that we are talking with, as like now I am talking with that one. So for that talk, then we have to recognize the text and we have to show the content as a text form. So that is actually we are having speech recognition. We can have speech recognition. One is that who is the speaker we are recognizing, or otherwise we are having that while speaking now, then the voice is going to be recorded and we are getting now that from the voice we are getting now the extracting the text. What informations we have deal with in the audio, that is also we are going to deal with now. Right. So this is we are having now. So where we are going to use that one and the speech to text, right? So in many places we are having now, right? So if you suppose one speaker is speaking something, and for example, actually that nowadays we are having now whatever that in the legal argumentations, the legal argumentation is going to be recorded, and also that in some country. They are having that doctors, whatever the doctor description, they are going to have recorded now. Then that is the live record of that voice is going to be recorded as a text, right? So that is we can see in the speech recognition. Now we'll deal with that. Okay, now we'll see that. So here we are having now that image. So whatever, so here we are having for that single image. We can see many images. Every image tells a story, right? So here you see this one. We are having a engine. Engine is going to fall down that from the fridge, or like we are having, right? So that is we are having now. We want to identify that what are the components are there, what are the objects are there in that video, in that image, and what are the summary we are getting now about that. Summary or story about the image we are going to get as a text form. Then how can we do now, right? So that is we are going to see now, right? So we are here we are having now deal with either 2-dimensional or we can have go for the 3-dimensional. Then how to make a stereo video, right? Stereo image, then to show that the 3D representation of that image, that also we are going to deal with. Right. So here can computer match human perception, right? So here we see that one human perception. So by our eye, right? So we can visualize everything, right? So whatever that we have seen that one, immediately we recognize whatever it is. It may be a text or it may be an object. So we are recognizing that one by the eye view. We are having identify that one, and then we'll go for that in background. We are having that our knowledge is going to explain that one, what is going on, what is that, everything is being right. Now we have to make the same effect into the computer is actually is very tedious, right? Then how we can approach or near to that our human perception in the computer, that is deal with the computer vision, right? Right. So here actually what are the image processing we can do now, right? Then through the image processing, how we have to recognize that or recognize or identify that objects. Then we have to identify that what are the identifications we need, that also we are going to deal with, right? Now you see this one here. We can compute the 3D shape of the world, right? So here nowadays actually whatever that we are having that video or some image, then it will show the 3D effect. Then how we are making it a 3D effect, right? So we have to give the multiple camera. Through the multiple camera, then we are visualizing one particular scene. Then the particular scene is going to be composed, or we are making that one to as a 3D effect image. That also we can see now, right? So here initially in 1991 actually that the movie called Terminator 2, where actually they are recognizing object and people, right? So for that they are using the computer vision. So we are in that one we are having an image. In that image, what are the objects are there in that one, right? So here we are having now the car, and within the car who are there, then where is the name plate or number plate, then in in background what it is, everything we have to recognize. So that is recognizing object and people is done on 1991, right? Now you see this one. We are having one image. Within that image, what are the objects are available here? Here we are seeing that one. Here we see that one. We are having that one object, right? Right. So here you see this one. This is one object, right? So that one is here. Right. So this is we are having a panel. So this is a panel, right? Then this also a panel. Then here we are having one photo as a one human photo is there, right? Then we are having now this is a building, and here we are having now that bus, car, then we are having that crowd of people, crowd and car. Like we are having now, then we are having now lamp post. Then you have to identify that each and every object within the image. That is our aim and the computer vision initially, right? Now you see this one. Here we what are the components are available. Components are objects, right? So here you see this one: banner, flag, then sky, building, face, and the street lamp, then bus, wall, then car. Like you have to identify the objects. So we are having recognizing the object. How we are going to have now, right? So now for that one, we have first initially what actually you have to do is whatever that image, first you have to pre-process. So pre-processing you have to do for analyzing easily, right? So what pre-process that we can do now? Enhance that image. So we can have that enhancing that image. Actually, we are using that camera, we are capturing that image. Then for capturing that image at that time, then we are having some background light or some dim light on everything, it will be there, right? Now, initially you have to do that image processing to enhance the image. After that, we can easily process and we can identify the components, right? Now you see this one enhancement. So here, actually, how we can enhance that image, right? So in that image, you see that each one part is pixel by pixel, array of pixel, right? So pixel is actually picture elements. So here you see this one in the screen, we are having now around 600 pixel, around 700 pixels in the horizontal and 700 pixels in the vertical. So 700 into 700 pixels are there. Then each pixel in the color, we are having now that the information about that each pixel is intensity, and then we are having the color. Color is called, we are having now red, green, blue, RGB. The basic color is RGB. So red, green, blue, and also intensity is the information about a single pixel. So we are having the collection of the pixels in the row and column wise as a matrix. Then we can see that one as image. Now in that image, we are having some blurring is there, right? So it's supposed we are having that shaking the camera, the blurring will be there. Now we can remove the blurring. So how far it's blurring, then we have to our jitter, then we have to remove that. So after removing that one, then the original image you will get now. So here you see this one. Here this is the image, and we are enhancing that image. We are getting now somewhat clarity. Right. So for that we are having some fuzzy logic we can use, right? Then we have to each and every pixels is going to have, then the neighborhood pixels are going to have analyze, and then what is the jitter, then we have to remove the jitter. So cancelling the jitter, then we can see that original image. So that is called enhancing. So you have to do that enhancement something about the image first. Then here, what's the main aim of the computer vision? So one example is forensic. Forensic is actually here we are having now that one particular person we want to identify. Actually, you are identifying that person as in that iris. Iris means that their eye. Then I is going to have that one as a unique for each and every one. So you have to do that analysis of that I and can identify that one which person who are, right? So that one as we have to. So here you see this one. within the eye, then we are having the eyeballs, we are having now the within that one, we are having now the curvily. So that one is having that unique for everyone, right? So that curvily, that one is going to have as like a your fingerprint. So that as like the fingerprint, then we are having that eye having that unique one. Then what actually we need, we have to segment the corresponding eye of a particular person. Then the eye is going to be rotate in proper manner, as you have to make it as a regular one, and then from that one, then they are analyzing the pattern within that black portion, and the pattern is matched with a particular person only. One particular person, then the pattern is matched. So using that one, they can identify a unique person. So that is actually, you call it as parent in that forensic, then they are identifying a particular person through eye contact, right? Then here you see this one. Here we are having now that how we can improve the photo, right? So here you see this one. Actually, nowadays we are having now that one, if we are moving car, the moving car is captured by the camera, and they can identify the number plate, and then police will give that. Suppose I also get fined through the police. So around 120 kilometers speed travel my car. Then the car captured by the camera itself, they identify the number plate, and using that number, then they are giving the notice to me. So how actually while moving that around that 120 kilometer speed, then if you are capturing that one, then the image definitely it won't be clear. But then they are doing now that one, resolutions we are making now to identify the number. So that is we are having now how we are improving the photos. Okay, so you have to give some high resolutions. For that you have to enhance that image, and then you have to identify a particular object as a number plate. Then they have to find out. Now here you see this one, that in that side you are having now. So here we are seeing now the number plate, right? So that is here number plate we have to identify through that one, right? So here you couldn't see that what is the content or data here. Now we have to analyze, and we are getting now that data. Saravana Kumar, is it clear now that by showing that circle and something? Anybody else?
Yes, sir, clear.
Clear. Okay. Now here you see this right hand side, the top right hand side, we are having that one image. Image is somewhat dim, right? The darkening. Then we can make improvement. How we can make improvement is the pixel by pixel process, and we have to give the high intensity. Then increasing the intensity, then we'll have that one another image, right? That like we have to increase, and then we can see that here we are having that eye. So we are separating that eye. Then through that eye we are having that block circles. Then we are identifying now. Then from that one we can analyze the photography about which person who are, right? So which person who are, we can identify that one. So that is we are coming. So low light photography, then we have to increase the light effect through our image processing, right? How we are increasing the intensity, right, of each pixels we can have, right? So that I told you that one, here we are having around the pixel is actually we are having now 100 rows, and it may be 300 rows, and we are having 120 columns. So row column we are having now that pixels is processed, and we are increase the intensity, and we can get the bright image. And also here we are having now that cell phone. Actually here nowadays we are having now that high resolution cell phone will be there, right? Actually that even though we are getting now that camera is somewhat less quality, then after getting that photo, then internally the image processing is going to do that one, improve the image. So you can see that one while capturing that one, it was somewhat blur, but while after getting that image, then that image is going to be clear. Now that here in the Instagram also, if you are posting that post, then photo, then they are enhancing that photo. Then only they are having now good effect. And then here this one, right? Next one, here we are having now that in painting and image completion, right? So that is here you see this one. this portion I want to remove. I want to subtract that portion, right? So that is it. So here we have to find out the edge, and then you find out that region where we are having that another component. Then we have to we are having now that interpolation to that one, and we are adding further component, and we can see that one, the subtraction here we can have now. So that also we are doing now that by image processing. Right. Now here we are having now why we have to go for computer vision, right? So we are having now actually nowadays we are in every places we are having camera, right? So for surveillance we are having camera. In actually, suppose you see that one in Chennai city, right? So if you are having a smart city, Chennai city or some other city, if it is smart city, then we are having a camera to anywhere else, right? So even though that we are having that in that signal, and each and every light post we are having a camera. Then we are collection of the camera, we can surveil the throughout the city through the camera only. So using that camera collection, we can see in each nook and corner of the particular city, and the surveillance camera is giving now that high security for police, or we are having that some disturbance is not happening through, and they otherwise it will store in any one of the camera, then we can capture that one. That is going on now. So here now we are having now billions of image. So here we are having now, if you see the Google, right? The Google image actually billion image is there, right? So, and also we are having that many videos. Now you can see YouTube. In that YouTube we are having numerous videos are there, right? Numerous videos, right? YouTube, or in the Instagram also we are having video, reels are there, like many videos and many images, right? So voluminous videos and images are there per day. So we are collecting now. Then if you are having the image, using that image only, then we can't process anything. So we have to do some image processing to find out the information, or you want to get some data through the image. So that is also very important, right? Now you see this one. So here you are having now. So this is, we are having that text image in Facebook. So this is actually related to Facebook. Then Flickr. We are having now, this is an identity. So using that identity itself, so here we are having one object. So this object is having that one identity. Similarly, here we are having Google's photo, then this is one identity icon, like YouTube icon. Like we are having many icons are there. So this icon can be recognized, right? So wherever we are having a building, if it is a Facebook building, definitely they will have that text as a Facebook in the nameplate, or building name will be there. So here you are capturing one building, then here which type of building it is, or what building it is. So we can see in some text. So we have to extract the text, and then we have to analyze that. So this is the particular building, right? And also here you see this one, here what is going on. So that is we want to have, right? So we are having 2 person and one here we are having now some vehicle is there, and another one we are having now some animal. So here we are having sea animals is there, like. So here we are having, this is one object, then 2 persons are there, then we are having something, right? And here we are, they are in the background is one sea. You can see having here. Hello. So like we are having now, we can see that whatever that common, right? So we are having now a huge number of useful applications. So here we are having many applications are there, right? So that one is, here we are having now the surveillance camera, right? So this also surveillance camera, then we can have now, then we can have now as a security purpose, we can have now that we can do some processing. Here we are having now, this is actually medical image. Then in that medical image, then we can see that some art, we are having that we are having that blood vessels, then we can see that one, then our nerves, then that nerves is going have that one, some damage will be there, then we can identify that one. That also is possible now, right? So here we are having now, suppose you consider now the railway track. So in that railway track, suppose you want to have that one railway petrol. So we have to give now two rails are there. Then is there any cut in between? So we can see that one through within the aerial camera itself. We can see that one whether that the parallel rail is without any discontinuity. We can see that one. So that also we can do now that processing, right? And we are having that this is we are having now that environment, right? So we are having the natural calamity. We can see that one. That also we can do now. Then we are having now. This is we are having now that space research. Also we are having now that image. Then through the so here we are having that aerial image. Using that aerial image, actually we have done one project as in that aerial image. We have to see the what is the field area. If suppose we are having a building, then above which we are having around 5 kilometer above 5 kilometer above the camera is there through that unmanned air vehicle. Then they capture the particular building, and we can find out the breadth and width of the building using the image itself. So we are capturing that image in the long distance, and also we are focus on that particular image on this terrain. Then from the terrain we are capturing. Then after that we have to do some process, and we can see that one what is the breadth and length of the building, and we can see that one, right? So the total survey on the field we can see through the camera. That also is possible. So that is a useful application, right? Like we are having numerous applications are there in the image processing. Right. The next slide shows the current state of the art, right? We'll see that one, right? So now here we are having now the optical character recognition. So OCR is nowadays we are using in many places, right? So for example, I told you that one, if you have number plate, the number plate we want to have that one, then we can see that numbers. So we have to recognize that number. So that how do you recognize number? Then we have to, each and every number is going to be recognized. For example, here you see that one number 8. Then this 8 is a image. Then from that image, you find out that one, this is the information. So 8 or some number, we can see that one. And also nowadays in the bank, we are having now, if you are giving the check is scanned. Then using that, while scanning the check, they will know that one, for whom account, account, then how much cost we have to give, and whether this is a valid signature. So this is, so you are recognizing that for whom we have to give pay the money, and how much we have to pay the money, whether this is a valid date, and here this is whether valid sign, then this is a valid check number. Like you want to find out that one. Automatically it will do now that scanning, and it will do now then that bank account is going to do that transfer the check. That also is possible, right? We are having this sort of manually we are doing now. Then that also we can do by computer vision. Now here we are having now the face detection, right? So here face detection is just we are seeing now where we are having a face, right? So here we are having 3 persons are there. Then for the 3 persons, then we can identify that. So rectangle area where the face is covered. So we are having now the 3 faces are covered. Then we can process only within that region only. Then we can identify that. So face detection is just we are seeing that the face is available. So we are having only 3 faces are there. Then we are having the region of face we are having now. Next, the face detection. So we recognition. So recognition means then we are having now that which person whom, right? So that is we are having now that recognition. So we can recognize the face as, so which person we are having. For example, in your class we are having around 60 students are there. Now through in your classroom we are having a camera. Just we are clicking one click, then it will show that the 60% head. So we are detecting the face. Then each face is going to be processed to identify that one students it is. Then we can put attendance within the fraction of second. So in that Excel sheet we can put it now within the fraction of seconds. That also we can do now. Now face recognition, right? So detection, then recognition, then you are recognizing and using the database, then we find out that all information, right? So here we are having now the roll pitch yaw. What do you mean by roll pitch yaw is here the head is moving, right? So head is moving now, the roll pitch yaw. So we are having now the rotate and then here we are coming in ya is we are coming that upward seeing, downward seeing, right? So that is actually as like that plate is moving now. The gyroscope will be there. In that gyroscope, what actually we are having now? The gyroscope is rotate. Then it will see that top or bottom. That is yeah. Then we are having now the pitch. We can have roll, pitch. So roll is we are having now plate is rolling, roll. Then pitch is we are having now that in the horizontal direction. Yaw is upward and downward. So roll pitch, yeah. So this is as like that. Our head also is moving now. The roll. So how much we are the head is rolled. That how much the yeah on pitches, right? Then using that one now we can process to make that original image, right? Now you see this one in that image. How do you they are recognizing, right? So for recognizing that one, then each features they are extracted, right? The feature is here we are having now this eye one feature. Right, then we are having some points, right? So here we are having now this is a dot is a point, right? So that point is going to be recognized, right? So that one is here, like we are having it maybe around 17 features, right? The maximum 17 features are there. Use the feature points. Using that features, then they can recognize which person who are. Right, so like each and every persons we are having now that the corresponding segments. They're using that segment and we are having a hot spot. Using the hot spot, then we'll identify that the particular persons. Right. So here you see this one. In that case, we are having this is the one face. Now that face is going to be recognized as Rakshana, right? Rakshana. Right? We are having now, right? So that one is this is Jack. How it is identifying now? Jack and Rakshana. Like they identify that recognizing the name. Now here we are having now the biometrics. So now nowadays in every places we are having finger biometrics is there. Then in near future actually nowadays in some companies they are having with the face recognition itself as a biometrics, right? So they are having now, even though in what manner we are coming now, then using that iris opening, then they can identify that one the biometric, right? So whatever that cut up they are coming now, but within that eye itself, then they can recognize. So you should not close your eyes and should not wear your glasses. Then you have to come now. Then we can see that one who you are. Like we can find out through eyeball, iris recognition. Right. So we are having now iris pattern is recognized to identify a particular person. Right. Login without a password. Right. Nowadays here you see this one. Your mobile itself, then it will say it will show your face, then mobile will open, right? In Apple iPhone nowadays is there. So you are who is that person, then for that person only it will show your screen. Otherwise it won't show that one, right? So the screen, the camera itself captures this and it will identify that one. Hello? Anybody else is having that query? Shall I continue? Okay.
Yes, sir.
Yes. Yes. Okay. So here we are having now. Then nowadays we are having now that the animal population or birds populations we can come. So for each bird they will give that ID. So as like that person ID number. So here for that birds also they are giving now that ID. How they recognize that particular bird, and then they will have that some tag within that birds. Then they will have recognizing the particular bird. And animals also, right? So we are having now that animal and something we can go for. Okay. Now here you see this one. Here we are having now the zebra, cos. So here we are having now that this one. We can change that one, right? So here we are having now the image synthesis. Synthesis means we are having now. Then here nowadays we are having generative AI is there. Generative AI. Actually, we are having generative adversarial network is there. Then through that one, we can generate your image, right? So here we are having now, you see this one here, we are having this image. The image is with the zebra. Now we can synthesize using that one. Instead of zebra, we can have now through the cars. That is also we can have now, right? So that is called synthesis. So we are having using that some other information, then we can impose something on that image and we can create a new image. So that is called image synthesis, right? So here we are having now, this is one image. Then we are having now that this is something. So by old image, then we are processing and we will get now a new photo. Right. So nowadays you can see that one black and white video is going to be converted into the colored video. So that is also we are doing now as a synthesis, right? And also nowadays we can see that one some generative AI, even though the person is dead, then they are making AI using that AI, they are creating that many videos of the particular person, right? For simple one example is actress Vijayakant, then is going to give now that in the Vijay movie. Like they can have some processing also we can do now. So that is called image synthesis. We are having now using some information, then we can generate a new image or new video. That is we are having now. That also we can do now, right? So now this is a simple example, right? In summer, how it is. Then if it may be a winter, what may be the improvements, right? So like we can have generate. So we can have now, right? So that is we are having some generation, right? The cars is zebra, right? The winter is summer. How the winter will be, how the summer will be. Like we can see that one, right? So like we can go for many processing. So the synthesizing that image also is another, right? Then nowadays we are having now the smart car, right? So almost in our car also something somewhat smart, right? But total smart is required now. Then we for all suppose you are driving a car, right? Then it will give that more commands about that one, right? So car nearby one car is approaching, then we are having the back in the back end around 10 meter, one more car is coming back. Like then it is giving that voice message. Using that voice message, the driver is alert and he is doing now the driving, right? Almost the driving, while the driving, then if he is doing some mistake, then immediately then it is giving command, then the person is alert and we can avoid the accident. So that is the aim of that smart car, right? Smart car, even though the driver is there, then the driver may have some sleeping mood. So at that time, then it will give out the information. So you are not alert. Please alert to travel, right? Like it will give now, right? So that is also is possible. And also the surrounding, we are having 4 camera is there, right? Rear end camera and forward camera, side camera, everything is there. Then that is actually we are having vision. So it is showing that images and videos we are capturing through the image and video. It compose and it will identify the anonymous situation is occur on that car. Then immediately it will give now the command or alert to that driver. Then the driver can cautious and they can travel the car smoothly. So that is also so Tesla autopilot, right? So that is we are having now that one they are driving that car, right? So that Tesla autopilot, then we are having now we are having the safety through the safety features. Then the driver is having now the car, right? Advanced warning system, right? So AWS actually we are Amazon Web Service. Now this AWS actually advanced warning system. So I told you that one. So it will give the warning to drive a car. While drive for the driver, it's giving the warning about that one, right? So here we are having now, see, within a single chip itself, then we can do now that vision. So here we are having this processor. Within the processor, all image processing algorithm is embedded into the processor. Single chip is enough. For example, in that your mobile. So we are having this chip, then it will do all image processing work, right? So if you are capturing that one photo, within that photo, if you want to find out the text, it will extract the text. That also is possible through the mobile. Right. And Google Waymo, that is actually it's a self-driving car, right? So in that car, there is no driver. Everything is through the camera. The camera is watching everything and it will process the image or video and it will identify that one where is the where is the path and how cautiously is the driver car without any driver. So the car is moving where you are having the target, and it will cover that using navigation and also the surrounding. Then it will reach the destination through the self-driver. Like nowadays, actually in Chennai, they are trying that in that metro train without that driver. They planned. Then they are having trial also is going now, right? So that one also is doing some computer vision effect. Then it is making nowadays. Then here you see this one, robotics, right? So robotic is whatever the human is doing, that one is going to do that one, right? In the Mars, the NASA is creating a robotic. The robotic is moving in the Mars. Then it capture that the images, and it will send the images to the world. Then the NASA is doing now research on that one, right? So in that one, then as like one man is sitting on that Mars, then they are giving all information to here. So that one is from the remotely, we are moving that robot, and the robot is capturing that videos, and is collecting that video. It is sending that video through that remote, and we are capturing that one, and the NASA is doing some project on that Mars, right? So wherever they want, then as like here we are sitting now, then operating the robot, and we are capturing that image. So that is also. Then in that Amazon picking challenge, right? So here we are having now each product we are having now. So which product is there? Then they will make a package, right? So they are packaging through a robot. So no person is required. So what order is coming now in the Amazon, it will identify that one. Then it will take the particular product, and it will pack in the box, and it will make a label about the destination address. Then it will send it out. One box is ready now. Then one person is not required, right? Then Amazon Prime Air, right? So we are at that we want to send it to the particular destination through drones like device, right? So that also is possible. So totally we can everything can be automated. So we are sitting in the laptop, and we are sending the order. Then automatically, then it will go to that server. Then the Amazon is giving that command to that robot. The robot is picking the items, and it will make a package. Then the package is sent to the particular drone with the address. The drone is going to give now that deliver the item to the particular. So for all cases, then they are having some computer vision, and it's doing now the process. Then only it is possible. Then, now in that medical, we are having now actually almost the medical, without any distract on the body, then they want to analyze. Then the one way is definitely we are having that image, capture the image, right? MRI scan, then CT scan, right? So through that MRI CT scan, then we can realistic within that particular portion, and we can see that one, right? So even though without any non-destructive, then it will show one particular region, and it will identify that one, right? And also nowadays we are having now that treatment through the holes, and we can make it the corresponding locations. Then if you are having that some tumor in brain, then they identify that one, and through the camera itself, and they can reach the particular region and extract the tumors, and they make clear without any disturbance, and within 1 week, then they can go for routine work. Such things is happening through the medical imaging miracles, right? Now you see this one here. We are having now nowadays actually we are having deep convolution neural network. The deep convolution neural network is a major processing on the image, right? So here almost successful one is actually deep convolutional neural network, right? So here we are having now, this is as like a human being, then all processes going to happen now, then it will identify the requirements, right? So that is here now you see this one convolution. We are doing the convolution, right? The convolution is actually what it is doing now. Then it is actually scanning that pixel by pixels, and region by region is scanning now. It is giving the information. And then we are having now that the average pooling, max pooling, concatenation, and the dropout fully connected. Then we are doing that in some soft max. These are all the layers, multiple layers. It is doing the process and it will identify the or recognize the whatever the need of the particular image analysis can do now, right? Through the deep learning, then many success are going to have now. Then, for example, here we are having skin cancer classification with the deep learning. Almost 92% is giving the good result, right? So that is the remaining 8% is somewhat complicated. Then that is they are having now, right? So that is they are making now, right? So these are all the multiple layers, right? Convolution layer, average pooling, max pooling. Then we are having concatenations, and we are having some what is not necessary dropout, and then we are having making the connections. Everything is there. Then we are having that optimization using softmax. We are doing now. Then we will get now the identification is required. We can do now, right? So this is we are having now using that many data sets. It will have the recognize or it will learn that information. Then a new image is coming now. Then it will find out that one whether the image is defective or not. We can see that one. So that is possible now through medical image, right?
Participants, please wait.
Sir, session is over or it's
No, sir, resource person has some issues in network. So we asked the resource person to connect, sir. Please wait.
oh sorry, sir. Yes, sir.
Any one of you, please.
Yes, sir.
In which place is our video is our lecture is stopped now?
Thought about deep convolution neural network, sir.
Keep convolution neural network. Okay. Current state of the art, right?
Yes, sir. Your screen is not visible, sir. You can please share your PPT.
Yeah,
sir.
yeah. Share it. 1 minute.
Yeah, we can hear you, sir.
1 minute. 1.
Yes, sir.
Is it
It is
visible
visible
now?
now. Yes, sir. Visible, sir.
Yeah. Okay, where we are that did I stop now? Is it right? This is medical imaging. Yeah.
Yes, sir. Yes, sir.
This is over, right?
Sir.
Yeah. Now this is we are having virtual and augmented reality. That is from that one is stopped, right?
Sir, yes, sir. Yes, sir.
Yeah. I will continue now.
Yes, sir. Please.
We are having that virtual reality and augmented reality, right? So that one is here. We are having now that flight simulation. That flight simulation, actually, how it is that one within the single room itself. Throughout the all walls, we are having a camera. We are having now that this one, right? TV as the screen. So screen. So the total walls are as like a screen, and it is simulated now that as a external field. And the person is sitting on the chair. Then chair in the chair itself, we are having simulations. Then we are doing now the as like a driver pilot. The pilot is moving now at the time. Then the background screen is moving now, and then he is having that effect as like original flight is he is running now. Okay, then then he is doing that all operations. Then they are navigate their flight in proper directions. Then they are land how then flight is going to move. That is also is possible through virtual reality. And we are having now the 360 video capture, right? So what I mean by 360 video capture, for example, you can see that one initially that in the Sanger movie, the Poise movie, then the hero and heroine is jumping. Then we can see that one around the 180-degree directions. We can see that that person at that same position. How they are making now? Then 180-degree direction they are having the camera at a time that capture that while jumping at the time capture, and then the frames are creating now that from 0 degree to 180 degree. Then we can see that one that in the 180-degree rotation of the same still of the particular actors and actress. That is right. So similarly, we are having now the 360 video capture. So the video capture many 360 degree, and we can capture the throughout the environment, and using that environment, then we can create the 3D image. That also is possible, right? Currently, actually, we are doing now that in image processing as here, autonomous vehicles, and medical imaging, and we are creating constructions, right? So before constructing that building, then they'll have now the simulation about the building, and then we are having the inspections. Some inspection means that I told you that on railway track inspections. Then everything we can do now. Then we can have the simulation of the flight, virtual reality and augmented reality, right? In some hazardous place, the person can't go now. Then at that time, then we can have that augmented reality. Then we can make it now. Then the person is sitting in somewhere else. For simple example is, we are having now that in that in that movie, right? Jeans movie. Then the Transmaster is doing now that action. Then the lady image is going to that action, right? So that is here we are having as like a virtual reality. We can do now that one. So same way, if a person cannot go enter into that one where the robot is going now, so the person is somewhere else around that one. Whatever he is doing now, the same is doing now the by robotic, right? Then here we are having some simple image processing. So one is actually the many important image processing is actually we want to segment the object. Before segmenting the object, we need to have that one, the edge detection, right? So here you see this one, how we are making that edge detection is, here it will scan line by line. So while scanning that line by line, now we are having that pixel is, there is no change in pixel. There is no change in pixel, right? Here we are having the change in pixel. So the change in pixel is put one dot, right? Next we are having here the change in pixel. The change in pixel is putting one dot. Here we are having now the changing pixel in one position, right? Here changing the, right? Like we are scanning line by line, then we can see the edge. It's a simple way of the creating that edge, right? So here for that we are having now that many algorithms are there. They are around many research was going on. Then they are having now this type of edge detections. Then using the filter, we are having edge detections. We are having now the some window. Then sliding window we can have now. Then edge detection, like they are having now many research was going on that the edge detection. Nowadays, then edge is going to have the proper detection, right? Now you see this one here. How I told you that one, the edge is detected, right? Now you see this one here. I told you that one, right? So this is we are having now the intensity. So intensity here, high intensity. Here we are having low intensity. So this is a high intensity, low intensity. The low intensity continue, and then we are having now the increase the high intensity. Now here we are having the variation is here. After that there is no variation. So variation only we are identifying. So that one is here the variation. So the edges are this variation only. So this edge and this edge, we are having that variations. We can see that one. Can you see that window? And whatever I drawn, we can see that one.
Yes, sir.
Yes, sir.
Yes. Right. Like we for that we are having that image derivative, right? It's a derivation, right? So what is the derivation now? The variation only it will identify now. The derivation is here. The derivation is variation. Here the derivation is nothing. No, derivation is zero, right? There is no change. Change is only the derivation. So change is here and here. So using the derivation, we can identify that one changes, and we can identify the particular spot of the variation. So that is the edge, right? So finally, we are getting now this is the edge and this edge. Then in between there is no variations, right? So that is we can do now, right? So for that we are having many algorithm. Just you see that one we are having as like a filter. Using the filter, the filter is convolute on that your image, and we can see the edges, right? So like we are having now edges, we can do now. I have for amount of time, just I'm showing now, and we can go for continuously, right? So x-axis and y-axis direction, and then we are having the multiple direction we can go for, and we can find out that one through the image gradient also. So we can see that one, this is image, and we are having that edges. So like we can have now that edge can be detected, right? So that is we are having now the edge portion. We can see that the edge detection you are doing now that your image and convolute that image with that one spike. Then you identify where is the spike, and the spike is the dots for the edge. So here simple example. You see this one. So this is we are having smooth gradient magnitude. This is not giving proper edge. Then we can do that further processing. You are making a thresholding. Threshold is we are having now that the blood is going to be removed, and then we are doing now that using that gradient, color gradient we can have now. So we are having that which circle is having that one color, another circle is another color. Like we can have now the variation of the orientations. And here you see this one. Here you are having now that blood. Then we can make it as a non-maximum suppression. So non-maximum suppression is the blood is suppressed and we can make it as a single line, right? So here we are having the single line is, then here we are having the blood is suppressed. Sorry, the line drawing properly, right? So they cannot draw properly. So we can see that one, right? So that is we are having now then one single arc, we can see that one. Here we are having now the double arc is that, then we can make it as that one using gradient. Now you see this one. So non-maximum suppression. Then we are having now that we are having that suppression, non-maximum suppression doing now. Then we can have now proper edge. Then we can see now, and then we are doing some thresholding, and then we have to make a connections. Then we can see that one edges. So after then we can extract the components, right? So the dog we can extract, the car we can extract, like we can go far through the edge. Right, and the image in that image processing we are having that many transformation, right? So now you want to show that image in many directions, right? So here for example the many animations are going on, right? Then on that animation we are doing now that through the image transformation only, right? So we are having one picture is there, the picture is then you are putting the picture on the table and we can see that what the same image is going to have now some changes. So that is we can do now that by image processing we can do some transformation. So what are the type of transformation we can have now, right? So here we are having translation, then we can have now the similarity, right? So here we are having this image we are having now. I want to rotate. Then we can have the similar image we can rotate now. Then we can have now that image we can move some other place, right? I'm taking this photo and I'm moving to somewhere else. Then we can have the translation. So how we are doing now the translation, then how we can have now, we can have a projections. That also we can do now, right? That image processing we can do now. You'll see that one by one. And so now you see this one. You are having a book. Now where's the particular book in that particular scene? Then how do you have now, right? So this particular image is going to have now that to rotate. Then we have to slant, and then we have to make it as an exact match with the component, right? So that is here we are having now. This is the this book is there. Yes, here. But many obstacle is there, right? So we want to see that one. So this is right. Now here what you have to scaling. So you have to fit with the scale, and then we have to go for that rotation. So we have to rotate that one, and we have to fix it now. Then after that, then we are having some other objects are there. Then we have to find out that whatever the object it may be, then we have to subtract that one, and then we have to find out that one. So this is the component we are having now. So what are the information is required? You have to translate. So the image is translated and image is rotated, and we are making a scaling. Then we have to reduce and increase, right? After that, then we find out the similarity, and you identify the particular book is there in that particular image. So that is the case we are having, right? Now we are having the geometric relations. What do you mean by that one? Here, this is why you are taking two photos, right? So this is one left side photo, another right side photo. Now we have to compose the photo into two, right? Into a single one, right? So we can't create at the time we can't make a that one. Then we can create, and then we have to merge. We have to fit that one, right? So for that we are having the geometric relationship we can do now, right? Directly go for now. So this is we are having now. So that left side and right side we are having now. Then we are having now that as like a mosaic we can make it as fit now, fitting that one, and we can create that object or the image in the two captured image we can have now. So that is we can do now through some processing, right? So we can do that filtering and wrapping, like we can go for. So here you see this one image, the image is filtered. Then filter we can make it in another function. So the XY pixels is going to process now. Then we are getting now then another pixel, some light effect. But while if suppose sunlight, how it is, like we can make it as now. Now we can have the image deformation, right? Deformation is the x-axis we are having extracting. So stretch the image, that also we can do now, right? So translation, rotation, and we are changing the aspect ratio as the way, right? Like we can do now, the image can be processed and we can fit it into that, right? You can see that the Aladdin movie, right? In that Aladdin movie, then one the PET sheet is moving, right? At that moving, then we can see that one on the PET sheet, we are having that images and we can see that changes, right? So that is we are doing now that the transformation only. Image is transformed into multiple direction and with the speed of translations, right? So we are having translation, rotation and scaling. That also we can do now, right? So this is we can do through the matrix. We are having that matrix manipulation, right? So here you see this one. This is one image. The image is going to be scale up. Scale up means then we are having a zooming the image. While zooming that image, just we are having the pixel by pixel, we have to increase the size of the pixels. Then only we can get the originality on the zoomed image, right? If you are extracting that image, then it won't get clear image. So what actually we need to have that each and every pixel is going to be zoomed. Then we are getting now the originality with zoomed image, right? So that is this matrix is going to be processed on your original image. Then we are extracting. Now scale is if 2 times. Then it will have that one 2 times increase, then 3. S is 3. Then we are having 3 times we can increase the pixel by pixels, right? And also we can have a rotation. So rotation is we are having the cos theta, sin theta. We can put it now in that matrix, and we each and every pixel is going to multiply it with the matrix. So we pre-multiply this with matrix, and we can have a rotation, right? So in around 360 degree, if you want to rotate, then we can do the rotation of that image. That also, so we are going to flip that image, or you want to rotate the image, and we have to make it as vertical, like we can go for that transformation, right? So for that we are having now then 2D mirror image. We are getting one image to mirror image. We are having that another matrix. Then we are having that mirror image at the diagonal line. Y equal to X line. Diagonal line, we are making the mirror image. So like we are having many mirrors, we can make it now as a tiles. We can see one single image as a copying the image, and we can see the total tiles with the image. So then like the pattern is going to be shown on within the wall itself with a single pattern to fill with as like a tiles. That also is possible, right? So like we are having now, then these are the possible transformations. So we can do at that time, we can do scale, rotate, sharing and mirroring we can do now, right? So through the matrix multiplication. So we are having now the one matrix is for translation, another matrix for rotation, another matrix for sharing. Like we can do now, then we can see that image, right? So that is going to have the continuously. If we are doing now, then we can see, show the image as in whatever form you want, or whatever projection you want. We can see that, right? Now we'll see that one. So this is we are having the homogeneous coordinate. Like we can have now that changes. Now I'll show that directly. I'll show that images, and we can see the effect, right? So this is we are having the transformation. We are getting now the fit now, right? Next we are having now. This is we are for the affine transformation. We are having this a matrix. Then the matrix is going to be multiplied. Then we are getting now the new image. Then we are having now that projection, right? So we are having this image. So we are having this as like a paper. On the paper we are having image. Then the paper is going to be slanting, and we can see that content, right? So how do you do that one, right? So that is called homographic. Homographic, for that we are having that this is a matrix. So we are changing the parameter value. Then the corresponding that one we will have now that orientation of the scene. We can see that one, right? Like this matrix itself is enough. Then the pixel by pixels is processing, and we are getting now that this image is transformed into that one. So that image we can transform into. So this is we are having now. This is a matrix for homographic. Then each and every value we can put now the required value. We have to put it now, and we have to multiply it with all XY pixels, and we are getting now that new, right? So this is the original image. Then we are processed. We are getting now this transformed image. So here also we are having original image, and we can have now the transformed image. So that is a projection we can do now. So we are having now, we do that, right? Like we are having now the homography we can do now. So this we are having the projections. We can have now that points, right? So this also we are having now the homography. Can do that one, right? So like we can go for homography and something we can do. You see now I show. Told you that one, right? So this is the original image pixels, and we are multiplying this matrix. We are getting now the transform. We can do it, right? So that is we are having the recognitions. We are having now as the components we have to recognize, right? So that is we do now as object recognition. So this is we are having now that this one as in that image. We are having that lamp post, and we are having now that crowd, and we are having that background building. And then we are having now the tree, and like we can have now, right? Then we can have now then object recognize, right? So in that object recognition, what are the difficulties are there, right? Now I want to see that chair. That's where is the chair, right? I want to show that one, right? So that is here we are scanning that your image, and we'll find out that we are having the similarity match of the chair. Then we'll find out, right? In that case, what are the we want to have that this object, right? Then what is the harness is there, right? So we are having many places. We are having now chair. So instead of the chair, we are having the components we are seeing now as a leg. So using that leg, it will identify that one many places. It's actually wrong recognition, right? So here we are having now that one is not. Now you see here we are having now that this is easy. In that one we are having now that the shift matching is a one technique. Then you are having a similarity matching, right? So the similarity matching we can do now that this is actually we are having single object. Then we can match it now. Then we can have now the pixel by pixel match we can do now, right? But here we are having the chair. The chair is varieties of chair is there. Now this is one chair, right? So we are having the back, right? So we are having this is one chair, right? So in that chair also we are having varieties. So this is another chair. This is another type of chair, right? Now here we want to find out the object, right? So we are having generic object category. So this is these three are chair. So chair in whatever form, then we will identify that one. This is the chair. Then how we can have the varieties of chair. Then you have to recognize the varieties of chair and you have to match with that one, right? So that is the difficulties we are having now. Then another one here. You see this one here. This right. So this is some creature. Then that creature is there in that tree, but we couldn't see that one, right? So through the iteration, we can find out that one. Right, then for that we have to do some bootstrap learning we have to do to find out that one, right? So that is we are having that through the edge iteration we can't do that. So here this is the tree skin and this one is same, right? Peel that one, right? So that is we are having now, right? And photography we are seeing that scan, right? This is and also right now here we are having as automatic driving, right? So for that driving, then we will identify that each and every cars, then left and right, and we have to see that one, right? So that's also possible now, right? Then photo organization, right? So in nowadays we can see that one here many advertisement, right? So in that advertisement, how we are there is having the photos, right? So the photo is we are having now that we processed and we'll make us attractive photo and then we'll fit it now into that advertisement. Then only that customer will go for offering that particular purchase, right? So that is also is doing now then by photography organization, right? Then this is we already seen that one, right? So now this how it is called now, right? So we are having now if you want to have that face recognition, then what's the problem, right? So camera position and illumination, shape parameter, like we are having now many varieties of factors are affecting. Then we have to make it as changes and you have to do that all rotations and all transformations and you have to do that image pre-processing and then we have to find out that image. So for that we are having now to some image processing. Right. Now that categorization, we want to classify that object, right? So nowadays you see that one. If you are having that object, around 30,000 objects, more than that objects are there, right? In the world we are having now, lakhs of objects are there. Then you have to recognize that object. Then how we can do now? Then everything should be there in the as image, and the system is modeled for that each image, and that the model is going to find recognize that particular image on the screen. Right, and here we are having now I told you that one, right? So the face is in some rotation and we are having some scaling and we have to do that one to get originality and then we have to find out the recognize the particular face, right? Then we are having now illumination, right? So this is a dark and through the light we are illuminating now. Then here we are having the bright light and here something another illumination. So like we can go for now the illumination effect we can see now and we can do that image processing through the illumination, right? If you are having the light in particular position, then how we can see that image, that also is possible, right? The scaling, so small size to big size, then we have to make it as scale. T formation, right? So this is we are having original. Is suppose it's changing the T formation, then how it will recognize that one? The car, this is a jeep. Jeep is some met with the accident. Then here you have to match these two jeeps, right? So that's also is possible. T formations you can do now. Right now the occlusion. Occlusion means there's some hiding. Now you see this one here. We are having a cars. The cars is moving now. Then in between that some occlusion is there. Then we have to fill that, right? So we have to make it. Then another one, the background clutter. So the background is similar to that one. Everything is a background. Then how we can how to recognize that one? That also challenge. Then we are having that intra-class variation. I told you that one. Chairs, varieties of chairs. Then this calls intra-class variation. That is a challenge. Like you have to identify that one, right? So the image recognitions we are having now. Then optical character recognition. Then face detection. Optical character recognition, face detection, and we are having now instant level recognition and something pedestrian detection. Like we are going to have many image recognition part, right? Then we are having now the image recognition is like that. We can go for, and then here we are having now the generation. So this actually is not a original person. It is generating. We can generate a new person with some information from extracting some information, and we can get it now, right? So this is produced by the generator. It's not a person, right? So these are all and these are all the original person. It's a system generated image, right? So that is here we are produced by a generator. So we are having a generative artificial network is there. Then through the generative artificial networks, then we can feed many images. Then it will generate a new image. Then using the generative artificial network also we can recognize something, right? So that is going on now. Here, this is not necessary, and we are having many data sets are available nowadays. ImageNet, actually, basically, we are having the ImageNet, and then we are having many data sets. These data sets are available in the World Wide Web. We can download it and we can do processing. Right? So nowadays, we are having the Python programming. Everything is there. We can easily do that. Right? Next one. So through the ImageNet, how many number of objects? 1,000 varieties of objects are there. Then we are having that images actually 14 lakhs and something is images are there, right? Like we are having now. So that images are there. Using that one, we can do many work, right? So that is simply example is here varieties of the object. Then we are having what are the types of objects we are there. Images are there. So these are the data set. Using the data sets, we design a model. We are learning the model. Then the model is going to be used to recognize a new coming images to the particular objects. Right? 1 minute. Right. Like we are having now, then many information is there. Right now, see this one. You are having that image. Then the image is find out this is the apple. This token. So that is the image classification we can do now through the data sets, right? So available data sets, then we have to match with that one. Then we have to. So what are the types of classification are there? Right? So we are having now many algorithms are there. So this is a cat. Then we are having now that algorithm to find out, right? So we are having now that total the direct image similarity match, and also we can have statistical analysis, and then we can have now that many latest model as the deep learning. We can classify that particular object with the corresponding category. So that also possible, right? So we are having that image as a in the form of the numbers, right? So image is represented by in the form of the values, right? Now within that values, then we have to find out that one within that value itself. We have to find out whether the cat, right? So here we are having the classification is giving now. Then is in the similarity is matched here. So here now we are having this value itself. Then we can. So here at final what we are getting now the 82% match with category cat. Then 15% match with the dog. The 2% match with cat. Then 1% match with. So here we are having now the maximum. So this is recognized as cat. So like we are having now that doing process, right? So like we will go for that we can do many processing now, right? So here we are having in Python programming, we can easily solve that one. So we are giving the input as image, and we are doing some algorithm, and we'll find out now what category it is. Nowadays, it's very simple through the, we are having now the PyTorch. We are having now that one as a package, that the package is giving now the image processing, and we'll get now that, right? So that classification and recognitions we can do now, right? So that is, we are having now many ways. So collect the database of image and label it, and then we can do some machine learning algorithm. Then the algorithm is going to be trained, and then it will use for prediction to find out the image, right? So here we are having the training the image with the data sets, right? The data is the trained images and labels with the label. Now it will learn that one. Then we are creating a model. Then using that model, then we can have now a new image is coming now. Then it will classify that one. So it's a simple way of having. So we are having a one machine learning model. We have to learn using that available set of object with the label. Now the model is ready for a new object is coming now. Then that particular category. That's also possible, right? So this is a way. Image, you are getting the features of image, and then we are having the training, and it's learning the classifier. Using the learning classifier, then it will identify the common objects, right? So that is the way of designing a model, right? So we are having many algorithms are there, the nearest neighborhood and KNN and a learning classifier and neural network and deep neural network also is there, right? Now I'll go for the directly to one simple cases as. So these are all the algorithms we can have now. Then that is going to find out the each and every object, right? So now, actually, we so linear classifications, and we can do now. Then we can get it now. Like we can go for this linear line classification we can have now, right? Like we are next. This is actually our work. Then how we are having now. You are on the paper. You are writing something. Now you have to find out what text is this as a electronic version. I have to make it now, right? So that is how we are having. So this is original image. The image is going to be pre-processed, right? So image is going to be pre-processed. So this is the image on the paper. We are scanning that our paper, handwritten paper, and then we are having now that we did the some image processing. We are subtracting the background and everything, and we are having now that this text. Right, முதலாவதாக மேற்கு மற்றும் அது அறிமுகப்படுத்தப்பட்ட பருத்தின சவுத்தொழில், right? Then here we have to identify the character by character. We have to extract that one, so segment that one. Then after segmenting, then we are having that feature extraction. Then the feature extraction is going to recognize a model, right? So we are having now that one convolution neural network model we are having now. Then here we want to have that one. This one is changing that one. So character by character, it will identify that one. So here we are having now the corresponding electronic version of the text. So one simple processing, right? So that is we complete that work, right? That one is here how we are making that one, right? So that is we are handwritten data sets and binarization, noise removal and verifications. Then we are creating that one data sets. So after getting all processing, we are getting now the data sets, right? So that the data sets we are creating now, then this is the data sets and how we are making now, right? So this is a scanned image, and we are having now some pre-processing, and then we are going to have that algorithm for this one as we are having now the model. Then the model is going to pre-process, and we are getting now as a good image. So this is a pre-processing of image, right? So how we are doing now the pre-processing on the original image to the cleaned image. Then that cleaned image is going to be trained to the model, and we are getting now the character by character, right? So using the convolutional neural network, how we are recognizing the character by character, right? So the character recognition is there, and we are having now the many layers. So convolution layer, pooling layer, right? Another convolution layer, pooling layer. Like we are having set up that one. At the end, we are having now that some connected, fully connected, and then we are having softmax, and we are doing now that activation, and we are getting now the recognition, right? So that is we are doing now. Then we are having varieties of that algorithm, the LSTM and the deep learning and CNN. Like we are having now that many algorithms we designed that one. In that one, the PyLSTM that FRNN, we are having, this is giving the good result. Yeah, we did now, right? So that is here. So first, after cleaned image, we are doing that now the segmentation. Then after segmentation, then we are recognizing, right? So here we are having the character by word by word, we are recognizing now, right? Here we are having now the ResNet 50 model. The ResNet 50 model, right? So here we are resonant 50 model, we are having now that one as, right. So here we are having the many layers you are going to have. At final, we are having now that one as a electronic information. Like we are having the character by word is finding now. At final, we are getting, right. So this is another one example now. The character by character, then line by line, we are getting now. Then final, we are getting, right. So this is the cleaned image, and then we are having now that one, and finally we are having electronic version we are getting as a final, right. Next, you'll see that automatic speech recognition. Kesavaraja sir. Until now that computer vision is over, is there any doubts you can ask? Then we'll go for the automatic speech recognition. Sir, Kesavaraja sir. Saravana Kumar.
Sir.
Shall I continue another 10 minutes?
Okay, sir. No problem, sir. You continue.
Is there any clarification for computer vision?
Participants, if you have any queries, please ask. Okay, sir. You proceed, sir.
I'll proceed, and then after that we'll have the question, right? So this is we are having now. Then the next topic is automatic speech recognition, right? So we are having now. See, can you see that window? Screen, Saravana?
Yes, sir. Visible,
Saravana?
sir.
Yeah.
Yes.
Automatic speech recognition, right? Okay. You see that one, right? So here I go some fast now. Actually, at 7:30 I have to complete, right, Saravana?
Yes, sir. Yes, sir. By 7:30, next section will start, sir. No problem. You can continue, sir.
Okay. Right. Now we'll go for that one, right? So here, how the human is identify that our speech to text, right? So that one is here. It's a simple screen. We see that one. So your voice is as a signal. Signal is going to through the ear. Then in that ear, we are having now that many components are there. Then it will recognize through the nerves, and it will then through that one, then our brain is going to process and find out the understanding the voice, right? So that is going to have now we are going to do that one as speech to text. We want to convert that one. So that is actually automatic speech recognition, right? So here we are having now the speech is stored in the acoustic signals. Then through the acoustic signal, then we have to recognize what text we are having now, what text they are talking now, right? So for example, here my number is 7390271. So this is a voice they are having now, right? Now that voice is going to be processed, right? How to do that one, right? So first we are doing the digitization, and then we are having the acoustic analysis of the speech, and then we are having that some linguistic interpretations. Then we are getting now the text, speech to text conversion we can do now, right? So that is what it is, the voice acoustic waveform. Then through the mic we are getting now the digitization, we are getting now the digital. Then we are having that
Sir, you are muted, sir.
Sir, your voice is not audible, sir. Muted. Sir, your voice is muted, sir.
okay, where you mute now? Shall I continue?
Yes, sir. Yes, proceed, sir.
Okay. Now, in that case of the text processing, the important point is here phonetics and phonology, right? And then we are having now, right? We are having now that we are having the syntax and lexical, and then we are having now the pragmatics and syntax and pragmatics, and then pragmatics to find out that. So actually, what we are having now that waveforms are there. Then through the waveforms we are having that word by word we are getting now. Some error may be there. right? Then we are having some the natural language processing technique. So we know that one, right? So while talking something, what maybe the next text we know that one, right? Like we are having now the spontaneous speech, then we can interpret, we can predict what may be the next text. Then here this expectation of the text, but some error will be there and we can rectify that one. So that is we can do now through the phonology, and we are having the syntax, and we are having the pragmatics. Pragmatics means we are having the conversation. In that conversation, what sequence of the text is actually possible. Now how we are recognizing that one, then some changes are there, then how we can rectify that one through the possible cases. Like we can go for recognizing the text. Recognizing the text we can do now, that digitization we can do now. Then after that, then we are getting now that speech, and from that one we have to extract the words, right? Then we are identify the phonemes, right? Each and every text phonemes we have to identify that one, whether it is a Tamil language or English language or some other language we have to do now, right? And also the speech of the each person is varying. Then the speech, and we are having that the loudness is varying. Then we have to normalize that one. Then after normalization, you have to make it as independent, and then we have to go for that speech recognition. Then we have to do some disambiguation through our language model. The language model we can do, right? So here we are having now many typically are there in speech. So the speed of the speech is varying from one person to another person, right? The slow speaker, then it will have the slow, then low fast speaker, they may have the fast speaking. Like we can have now the so speaker by speaker it vary, and then we are having the speed, and then the style of the speech may vary. Like we can go for many pitch, and here we are having loud length, loudness, everything is varying. So these are all the challenges. So through the challenge, then how do you make that one? Whether we can do the template matching, or we are having knowledge-based approach or statistical approach, we can do now the automatic speech recognition. Like we can cover 3 ways, right? Template matching. Template matching is not possible for all cases. Just if you are having that pure image on particular person, the particular person is speaking the same style, then we can go for template matching. Right, some variation is there, we have to go for some knowledge based. Knowledge based means the rule based, right? So here if it is he is talking something this word, then he will use the next word like that, he will use the next word like as like the Ngram model we can do now. Then we can find out that what is the expectation, then what he is speaking, then we can go for that one, right? Like we can have now that, right? So like we can go for the automatic speech recognition. This is actually we need to have the spontaneous speech recognition. Spontaneous speech recognition means what the live speech is going to make it as a text, right? So if you are having now that one person is in the stage, he is talking now. At the time, then we are seeing the content into the TV. At the time, then the text will come the underline. So that one is the spontaneous speech is converting into the text. The speed of that processing is going to have varying. So for that, we have to do this. Actually, here also we can do that deep learning and machine learning techniques nowadays is giving the helping hands to many work, right? So here we are rule based, and then we are having now in that rule based how we are getting now, right? So that is we are having now that text, and the text is converted into the corresponding words. Statistical based and machine learning hidden Markov model we can have now, right? So the hidden Markov model, he is talking something, then how the phonology is there, then from the phonology, then what's the statistical possibilities there, right? So this may be this one, or this may be that one. So which one is high probability, and then it will recognize that one. Like we will go for the hidden Markov model for identifying the character by character, word by word, it will identify that one, right? On, and on. So this is the this is phonology. Then using that phonology, then it will identify that one word on, right? So we are having that like many models are there. Then in that model, we are having statistical value. Using the statistical value, the high value statistical is going to have now as recognition. Almost the hidden Markov model is giving the 92% result. Then more than that one, the 8% is we can use the language model to modify that one. So language model we can use to smoothing that errors, right? So we can rectify the error through the language model, right? We are having now the noisy channel. The noisy channel we can have now suppressing the noise nowadays are there, right? Whatever the speech we are having now, one camera is there in the speaker, another camera is the environment. So environment we are getting the noise. then our speaker is speaking with voice and noise. Then the noise is subtracted from that camera, and without noise we are getting now the pure image, pure text, pure voice. Pure voice only we are expecting. Then through the voice, then we can process now, right? So that also is possible now. Then we can do that, right? So we are having even the noise channels, right? Like we are having now that many automatic speech recognition is there, and also nowadays we can combine the computer vision as well as the speech recognition for making the disambiguation. For example, our lip movement is going to give now that this word he is talking something, but the voice is getting something different. But his lip movement, we can have that image processing, and we can recognize, right? So some you can see that one. Some deaf persons, they recognize their our speech through the lip movement. So through the lip movement, we can see tell that one what he is talking, right? So one movie actually that Wake is mimic that a person is a long distance, he is talking something, and then by lip movement he is mimicking that one, right? Like we are having now, then we can recognize through image processing on the what's the lip movement, what's the eye, so in what mood he is talking now, then what text he may talk, then what information he may talk. Like we can have now, then extra model we can add it with to improve the text recognition. That also is possible through the computer vision, and combine together the speech processing, and we can recognize the speech to text recognition and improve through the image processing through the lip movements, and we can predict some text. Then the prediction text and the voice text is matched, then we'll give now this output of that text. So by that way we can improve that signal processing also for speech to text transformation, right? Okay, here I will stop here. If you are having any doubts, you can ask now.
Participants, queries, please.
For one of time, I have to actually what I told you that one. I'm going to rush up that one. So if you are having doubts, you can ask now. Sir, tell me 1 minute, sir. We need PPT, sir. PPT, actually, Saravana Kumar, you are sharing that one, right?
Okay, sir. Okay, sir. We will share, sir.
Okay, Saravana Kumar will share that one PPT. Any other queries? Actually, he is making one more query, that chat box. We'll see that one. Chat. Okay. Any query? Sir, what is the scope for an illegally for vehicle detection system using computer vision? So here we are having now, okay. Actually, we are having now that sparking slat. So in that sparking slat, every time then we are having a camera on that sparking slat. Then the camera is watching that which vehicle is there in that park, right? So they are having that image. Now while parking that one, then it will recognize that one. The intended user is using that particular parking system or not, right? If a new car is coming now, then it will immediately identify. Then it will give that information to the user. That is possible. Clear? Who is asking that question? Please unmute yourself and you can have ask question in the right. So in that chat is moving fastly. I couldn't read everything is properly. Can we get YouTube channel, right? Oh, you Saravana Kumar, you are placing it in YouTube text channel.
Yes, sir.
You are recording, right?
Yes, recording the session, sir.
Yeah. So the
Excuse me,
recording. Yes, tell me. Please ask question.
Sir, can we use the computer vision for the micro Doppler signature for the classification, sir?
Which micro?
Micro Doppler signature, frequency time variant signal.
Signature, handwritten signature.
Yes, sir. To
Yeah,
identify the
actually
vehicles, sir, aerial vehicles.
Aerial vehicle.
To identify the aerial vehicles, can you use the computer vision?
Various vehicle. Correct.
Small, sir, like small vehicle like helicopter, mini helicopter, spy bird, like that.
Yeah. Actually, what actually we need is that the data set need, right? So all type of cars, all type of buses, and everything is we need to have as a data set. Now we can have a model. The model is trained with the data sets, with the labeled data sets. Then the model is having that properly trained. Now, whatever the vehicle is, new vehicle is coming now, then it will categorize that one which vehicle it is. It's possible.
Thank
The
you, sir.
important is here the data set, right? So you have to collect the data set of all vehicles. Then around here lakhs of data, lakhs of vehicle images. You should have that one, and you have to train that your model, whatever the CNN model, or we are having the LSTM or something, right? That model is going to be trained. Then now that the model is ready to whatever the new image you are feed into that particular model, and it will show that what category of that device, the vehicle it is. Correct? Then that model can be used for live system also. So live traffic, you want to find out how many number of vehicles is going on, how many number of cars is moving, how many number of buses moving, right? Like we can have now that that also possible. Correct? Sucheta Patil, correct?
Thank you, sir. Thank you, sir. Understood.
Yes. Any other questions?
Sir, shall we conclude, sir?
Yeah.
Very much, sir. Now
Thank you, Unandal. Thank you,
request
Unandal.
Now I request Mrs. D. Sindhu, Assistant Professor, to give thanks to our chief guest and also to introduce the next session chief guest. Ma'am, please.
Good evening, everyone. I am honored to have the opportunity to deliver the vote of thanks for today's session. One, I would like to extend a heartfelt thanks to our resource person, Dr. S. Lakshmana Pandian, sir, for his insightful speech and for taking time out of his busy schedule to share his knowledge about computer vision and speech processing in this FTP. Thank you, sir. Thank you very much, sir.
Thank you. Thank you. Saravana Kumar, shall I
Now
leave now?
Yes, sir.